Welcome to Tennessee's at-home learning series for math. Today's lesson is for all of our sixth graders out there, though all children are welcome to tune in. This lesson is the fifth in our series. My name is Reggie Caruth and I'm an assistant principal here in the state of Tennessee and former math teacher. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson if you haven't seen any of our others. But it might be more fun if you go back to our previous lessons, since we'll be talking about things that we previously learned today. Today we'll be learning about modeling inequalities to see that they have infinite many solutions in mathematics. Before we get started, to participate fully in this lesson today, you need paper and pencil. Y'all ready? Let's jump in. I'm excited to spend time with you today diving into inequalities. Shout out to all of you sixth graders that remember working with inequalities. We will work with number lines today also, so get your pencil and paper ready. We will start out by discussing what each of the following statements mean, and I want you to think of possible amounts of money that could fit in a given statement. Again, I'm going to give you some statements, and I want you to discuss what each of these statements mean, and I want you to think about the possible amounts of money that can fit in a given statement. Y'all ready? Let's do this. So, here's our statements. Our first statement, Caleb has at least $5. That's our first statement. Our second one, Tarek has more than $5. Next one, Vanessa has at most $5. And last, Lee Chin has less than $5. All right, so what are some possible amounts of money that can fit into these four given situations? I'm gonna give you a second to think about that, and I want you to figure it out. I want you to pay attention also to key words. So I know that all of your amounts were centered around $5. How much money could Caleb have? He could have $5, $5.10, $5.90, $6, $7, $8, $9, and going and going and going. More simply, he could have $5 or any amount greater than $5. Is that what you got? So how does this statement about Tarek differ from the statement about Caleb? So Tarek has more than $5, but he cannot have exactly $5, where Caleb might have had exactly $5. So what does at most mean in Vanessa's example? So Vanessa could have $5, but no more than $5. So she can have less than $5, including $4, $3, $2, $1, or even no money at all. She can even have negative amount if she owes someone money. Lee Chin cannot have exactly $5 when you look at hers. So how do you know? because her problem says she has less than $5. Were your answers within the given constraints? We will continue to carefully look at words and phrases that allow us to know we are working with inequalities. Get your number lines ready. Let's go. So you did a great job in brainstorming possible numbers for Caleb, Tarek, Vanessa, and Lee Chen. We're going to take this information and look at ways to organize it. I would like for us to write both an inequality and draw a number line for the 4 situations. And then we're going to discuss them. I need your help, so please jump in at any time you have any responses. So again, here's my situations, and this is what we're going to do. So I want you to go ahead and start writing inequalities and number lines for each of these situations. And I'm going to go grab my number lines. So the first inequality and number line we're going to create is for Caleb's situation. So let's write our inequality. It says Caleb has at least $5. So my inequality I'm going to write is, I'm going to use C for Caleb, and he has at least $5. So that means I can go ahead and know that he has anything greater than or equal to 5. So now I'm going to plot this on my number line. So when I go and put my circle, where am I going to put my circle? On the 5. Is my circle going to be open or closed? Correct. We would draw a solid circle over the number 5, and then the arrow to the right to show that all of the numbers and greater than are part of this solution. So again, this is going to be solid, so I'm going to fill it in. And then now, I'm going to do everything to the right of 5 to let me know that all of these are part of my solution. Let's look at Tarek's. We're going to look at Tarek's situation, and we're going to create an inequality in a number line for him. So the situation reads, Tarek has more than $5. So how can we show this inequality? You're correct. I can do T is greater than 5. I want you to think about why we use just the greater than symbol and not the greater than or equal to symbol here. Correct, because I know that the 5 is not a part because we know that he has more than 5. So where am I going to place my circle on this number line? Correct, we want to place our circle on the 5, but this time, will it be solid or will it be open circle? It should be an open circle because 5 is not included in our solution. So I'm going to do an open circle on 5. Then I'm going to do everything to the right of 5 because everything to the right of 5 is going to be included in my solution. This open circle lets me know that it's going to start here, but it's not included in my solution. Got that? Let's look at Vanessa's. We're going to write an inequality and draw a number line for Vanessa's situation. So again, our situation says Vanessa has at most $5. So how can I write this inequality to reflect that? Correct. I can write that as V is less than or equal to 5. Great job. Where V is the amount of money Vanessa has in dollars. How would you show this on a graph? Correct. We would put a circle on the 5 and then the arrow towards all the smaller numbers. But will this circle be solid or will it be an open circle? You're correct. It should be a solid circle because it's going to show that 5 is also a part of those solutions. So I'm going to do a solid circle on 5. And I'm going to do everything to the left of it to show that 5 and everything to the left, or smaller than 5, is included in these solutions. Y'all got that? Y'all are doing a great job. Let's do another one. Our last situation is Lee Chen's. So Lee Chen's situation says she has less than $5. So how am I going to write this inequality? Okay, so I'm going to write that as L, for Lee Chen's amount, is less than 5. So that's my inequality. Now I'm ready to graph. Is my graph going to look exactly like Vanessa's or different? I want you to think about if it is or not and why not. Correct, they'll be similar, but they won't be exactly the same. So my circle on this graph will be open on the 5, because that's going to remind me that 5 is not included in my solutions. And then I'm going to do everything that's smaller than 5. Is that what you got? Remember, L represents the amount of money Lee Chen has in dollars. Good job. So let's do another example and work through this. Y'all did great with these statements. Let's do another. I'm going to erase my board. I want you to get your pencils and paper ready for this next problem. Here's my next problem. My next problem says, Kelly works for a quick oil change. If customers have to wait longer than 20 minutes, the company does not charge for the service. We're going to show the possible customer wait times in which the customer has to pay. Again, we're going to show the possible customer wait times in which the customers have to pay for their services. So how is this example different from the first ones we just did? Correct, it does describe a real-world situation. What does the second sentence tell us about the wait time for paying customers? Correct, the oil change must take 20 minutes or less. So how will we show this on a number line? And I want us to try it. So we're going to try to show this on a number line. So I'm going to go ahead and draw my number line. I'm gonna draw it right here to the side. I'm gonna say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm gonna give you a second. Based off this problem and all the information we know, I want you to draw this situation on a number line. All right, so because 20 minutes is part of an acceptable time limit, we will use a solid dot and shade everything to the left, or that's less than 20. So I'm gonna go to 20 because I know that's where I'm going. And I'm gonna use a solid dot, and I'm gonna do everything less than 20 or to the left of 20. So how many solutions are in this solution set? A lot of solutions, correct. We call that infinite many solutions because it can be at 17. I can do 2 is included, 12 is included. What about 8? It's included. 19 is even included. And I can keep going and going and going, so on and so on. And all of these will be acceptable answers for Kelly to change oil. So again, no matter which one I pull, I can pull 14, which is 14 minutes, 6, which is 6 minutes, and all of these, because they're to the left of 20 or less than 20, and it also includes my 20, it's all possible answers. So good job. So let's try some together. We will need to read the given situation and interpret what is going on, and then we're gonna write an inequality, and we're gonna draw a graph. Remember, the number line is a visual way for us to see that the solution and confirm the numbers make sense. So here's our problem. Jamal has been mowing lawns to save money for a concert. Jamal will need to work at least 6 hours to save enough money. We're gonna write an inequality to represent this situation and draw a graph for this solution. Let me give you my problem. And I'm gonna read it again. So again, here's my problem. It says, Jamal has been mowing lawns to save money for a concert. He will need to work at least 6 hours to save enough money. Write an inequality to represent this solution, and then graph the solution. Here's your number line. You're gonna create an inequality and graph it on the number line to show this. How would we represent Jamal working at least 6 hours? I'm gonna give you some time to try it. I'm gonna erase this other number line. All right, you all think you have it? I'm gonna read the problem again. Jamal has been mowing lawns to save money for a concert. He will need to work at least 6 hours to save enough money. We're gonna write an inequality to represent this situation and then graph the solution. So what are some key words here that I need to know? I know that he worked at least 6 hours. So I'm going to create my inequality to reflect this. So at least 6 hours, I'm going to create, or hopefully you create it. X, is it going to be X is greater than, less than, greater than or equal to, or less than equal to? Correct. X is greater than or equal to what? You're right, 6, which 6 stands for my 6 hours. So this is our inequality. Now let's graph this on the number line. Where am I going to place my circle? Correct, on the 6. Is that correct? Should it be an open or a closed circle? You're right, it should be a closed circle. Why a closed circle and not an open circle? Because this closed circle is going to let me know that 6 is included in our solution. So now, which way am I going to do my line? More than 6 or less than 6? So to the right of 6 or to the left? You're right. Everything that is greater than 6. All right, so what are 4 possible number of hours that Jamal needs to mow for him to be able to go to this concert? Correct. 8 is a reasonable amount of hours. Yep. 14 is a reasonable amount of hours. 18 isn't a reasonable amount of hours. And 22. Those are the numbers I see, but what about 11? Is that still reasonable? Yes. The reason why 11 is still reasonable is because it still falls under this solution set. How many numbers are in my solution set? Think back to that previous problem that we talked about. It is infinite solutions because it keeps going and going. If he decides to work 50 hours, it's still going to be a part of this solution because he is working at least 6 hours or more to save that amount of money. What about if I said 2 hours? Would that still work, or would that still be true? You're right, 2 is not, because 2 will not fall under this solution set. So he would have to at least work 6, and 2 would not make that this inequality situation true. Whew, you all are doing a great job. This has been amazing. So again, let's just recap some things that we talked about today. So when do I use a closed circle on my number line? Correct, if that number is included in my solution. When do I use an open circle on my number line? When I'm graphing. Correct, if that's where I'm starting at, but that number is not included in my solution. Kind of like in those same situations when we were talking about Kara, Lee Chan, Vanessa, and Tarek. All right, you all, great work. Today we learned about modeling inequalities to see that they have infinite many solutions in mathematics. Remember, what is infinite many solutions? That means there's tons of solutions that could be a possible answer in this problem. I hope you're seeing both similarities and differences in equations and inequalities. Can somebody tell me a difference? You're correct. Equations will have one answer as a solution, where inequalities can have more than one answer, or as we just learned, infinite many solutions when we're doing these. You sure did do a great job with your number line diagrams. After this video, you have some problems to practice on your own. When you're practicing these problems, I want you to go back, look through all your notes and all the previous problems to see if it helps you as you're solving all these problems. Good luck and do your best. You all, boys and girls, I have enjoyed doing mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning series. You all did a great job. Pat yourself on the back. I'm so proud of you all. Bye. See you next time.
Before you take a drink, do you think we can make this water rise to the top without putting any more water in there?
Yes.
How?
If we put some ice into here.
How many do you predict can fit in there before it goes all the way to the top?
I think 7.
7? Can you count them with me? Let's count. 1, 2, 3,
4, 5, 6, 7, 8, 9, 10.
Do one more. Daddy dropped it.
11.
You predicted it would take 7 ice cubes, and it took 11 ice cubes. So, did it take more or fewer ice cubes?
I think more.
You think more? You're right, it did take more. Now, you can take a drink.
You don't have to be a great reader to create a love of reading in your child. Just having books in the home can help. Let your baby hold them. Read with energy. Try using different voices for characters. Use the pictures to spark conversation. Engaging with books every day at an early age creates a love of learning and builds strong thinkers. Enroll your child at governorsfoundation.org to receive an Imagination Library book each month at no cost.